Welcome. We have a challenge me, guys. Challenge me practical VLSM. So variable length subnetting mask. Let's see if we have this concept down pat. First off, let's check our scenario. We Route Stuff Inc. have opened their headquarters up in Little Rock, Arkansas. The above topology will be the layout of the facility. Now, using VLSM, structure the subnetworks within the allotted addressing block of 172.31.00/16. Be sure not to waste addresses, as the company has planned expansion sites in 3 major cities within the next couple years. Now, what we've done up to this point is we've always found our largest network, and that's our chop, and we're going to just make a bunch of networks that size. Well, a network that accommodates 87 hosts isn't necessarily the same thing as one that accommodates 12. We would end up with a lot of wasted addresses. So here's the 3 things they want to know. Number 1, how many networks will be required to accommodate the site? List networks you would structure with net ID and subnet mask values. And list the unused portion of addresses for future planning. You know how this goes. We're going to pause the video. You guys are going to work through this. You're going to come back and we're going to see if your solution is the correct solution. See you on the other side. Alright, here we go. Here's what we're looking at. Initially, we have a network range of 172.31.00. It's a /16, meaning we run from 172.31.00 to 255, 65,536 hosts. That's a large network. Looking here, we have to figure out how we're going to chop this up in the smallest amount of sizes just to accommodate the hosts that we have available. Then determine what those networks are. Finally, we're going to list our unused portion, which will be available for future planning. Well, we definitely have enough to accommodate these hosts. 65,000. That's not crazy to think that we can squeeze these into that block. We'll do that without a problem, but let's do it so that it makes the most sense. Problem 1. How many networks will be required to accommodate the site? Well, what do routers do? They route data from network to network. So in this scenario, we're going to picture networks. Every interface coming off here is the establishment of a brand new network. Layer 3 breakups. Okay? We have one network right here of 20 hosts. We're going to have another network right here of 12 hosts. We'll have a network here of 25. A network here of 87. And do not forget about these guys. That's a network. And there's another network. Now this is obviously our public interface. We do not have to worry about that with what we're doing here, as we're dealing with a private range, and these are the networks we have to accommodate. So we have 1, 2, 3, 4, 5, 6. So total networks, 6. Next thing that we would have to do is to determine how we would divide these networks up. Well, as we saw from our VLSM video, we always have little cheat blocks like this where we can say, how many hosts do we need? This guy right here will accommodate a total of 126 hosts if we do a /25. Now we started with a /16. That means we're jumping all the way into this 4th octet with some of these sizes. Now remember, we had one of 87. We had a network of 25. We had a network of 20. We had a network of 12. And then we got a couple little networks which are basically point-to-points where we have 2 hosts and 2 hosts. How are we going to accommodate them? Well, 87 is going to fit in a block here. 25 and 20 both are going to fit into these kind of blocks. /27s. Network of 12, that's going to jump into one of these type blocks here, /28. A 2 and a 2, they're going to jump into these /30s. We're dealing with basically 4 addresses, a net ID, a broadcast, but just 2 hosts in there. Okay? Let's see how we would divide this up so that we can logically make sense out of this. So again, 6 networks. So the way we want to begin dividing our networks is start with the largest network, which would be this guy of 87 hosts, and work our way back. And we saw the reason being is that these smaller networks, they have much more flexibility in where they're going to start and where they will begin. In other words, if we use the /27, he can start at 0, 32, 64, 96, 128. However, if we had to accommodate here and we went with a /25, which is what we'll do, he can only start at 0 and 128. So if we tackled a /27 and a /27 and we went 0 and 32, we knew that we stopped at 63 for this second network. 64 to 128, well, that's dead space. We might be able to squeeze this smaller guy in there and maybe these two in there, but we will come nowhere near 128, which means what we will end up with is space in between all of these subnets and this subnet, which is basically wasted. He can only start at 0 and 128, so it doesn't make sense for us to use all these and maybe stop right here. And then what are we going to do from 96 all the way up to 128? We can't use it unless we end up with some more smaller networks to plug in later. But instead of doing that, we make this nice and simple. We start with our largest network and we build from the largest down to our smallest. Let's divide this first one up here. 172, 31, 0, 0. We're going to go with a /25 because he will accommodate 128 addresses or 126 hosts. That is plenty. We need 87. So that network is going to extend from 00 to 0127. Divide that. That's our first network right there. /25. 31, 0, 128. We take our next largest network, 25 hosts. This guy's going to be the same size, because if we went with a /25, which gave us 28 hosts, let's put them over here, /25, it's networks of 128 minus your 2. /26, divide that in half, it becomes a network of 64, 62 hosts. A /27, that becomes a network of 32 minus 2, 30 hosts. That accommodates fine. If we go any further, /28, down to a network of 16 or 14 hosts. That might be useful coming up, but for the next two, our next two largest ones, this is where we're at. So we'll take this guy, /27, which will give us 30 hosts to use, and he's going to run from 172, 31, 0, 128 down to 159. There's a network, 172, 31, 0, 160. We're going to grab another 32, okay? Because this guy's out the way now with the 27. We're going to take him out the way with the 27. And we're going to have a network from 172, 31, 0, 191. Okay. Divide him. We're down to 12 hosts. We go here with a /28. Now we're going to run from 172, 31, 0, 192. That's our next address. All the way up to 172, 31, 0, 207. 192 to 207 gives us our block of 16. 14 usable hosts. We have 12 in there. And we cannot forget about these guys. Point to points. Now from a point to point, we're going to go /30, or a mask of 255, 255, 255, 252. And what that will give us in this example, let's clear this. Just took this guy, our next network address was 208, and I said we're going to go with a /30. It's going to give us a network of 172.31.0.208 to 172.31.0.211. That's one network. That means we have point 209 to point 210. We assign one to this interface, assign one to this interface. That network is complete. Okay? That will give us the blueprint for this guy as well. /30. He's going 172.31.0.212 to 215, meaning 213 and 214 would be our point to points in here. And we would have accommodated all of Little Rock, Arkansas. Our unused portion, 172.31.0.216 is our next available address to 172.31.255.255. Now what we probably would do is look at Little Rock and go, you know what? We're going to give that site a /24. We'll give them everything from 172.31.0.0 to 172.31.0.255. And then we'll let everything else run for remaining sites from 172.31.1.0 through 255. Because as we can see, we have such a large block. This is our private area, such a large block. /24 would do more than accommodate everything in here. It would leave us some unused addressing space. .216 up through 255 of our 172.31.0 block. We can write that in here, 172.31.0.216 through 255. That could be what's left over here at Little Rock. This could be what's left over here inside the organization. Now we can begin dividing up all of our future sites, and maybe if networks stay this size, we could keep /24s there. If we need more at a spot, we can give them a /23 or a /22. We have plenty to work with. We started with a /16. That accommodates everything. There's a good feasible solution right there with very little wasted space. Alright guys, well that's a solution there. We got a lot of writing all over the place here. Hopefully you're able to follow this. So we have a network here, a network here, a network here, a network here, as well as two more networks over here, two /30s. We have an unused range. Now logically we would probably grab a 24 to give to this site and break that up, and that would be our unused for Little Rock, Arkansas. This would be unused for We Route Stuff Incorporated. Hopefully you came up with a very similar solution. If not, and you need a little more work or understanding around the VLSM concept, please check out the VLSM video. Other than that, take care. I wish you all the best. Thanks.